Hello, good evening students. Let us try to understand the states of system. Okay, states of system is what, student? There are certain thermodynamics properties are there, student. Okay, so dear students, if you see, if the we are having the one gas is there, right, student? One gas is there. Okay, or you can say, you can easily select, student, that is water. You can select here. Okay, so water you are selecting. So what will be the state of water at 0 degrees Celsius and 1 atm pressure? So the state ice is will be the water will be in the form of ice. Okay, ice. So the state is, if you they are talking at 0 degrees Celsius, the state of system is what, student? This is the solid. Now what we are going to do is, student, increasing temperature. You are increasing the temperature. Increasing temperature. So dear student, when you are increasing the temperature, what will happen the state of the system? What do you think? If suppose T is equal to 25 degrees Celsius and the pre is equal to 1 atm. Okay, you can tell me, student, state. So if the temperature is increasing, that is water will become, that is liquid, student. This will become the liquid state. Yes or no? This will be the liquid state. Means state is getting changed. How it is getting changed? When you are changing the temperature. So let us look, let us have a look, student, how the state of system means. When the fundamental properties such as pressure, temperature, volume, number of moles and composition have definite values. Okay, when the fundamental properties such as pressure, temperature, volume, number of moles and composition have definite values, the system is said to be in any definite state. Okay, the system is said to be any definite state. When there is any change in any one, like temperature, pressure, volume or any one properties, it is said that the system has undergo change of state. So that is at that condition, that is the state of system is getting changed. So this is what is the state of system. So if temperature, pressure, number of moles of gas, volume is constant, the system is will be the definite state, student. But when there is any change in one of these properties such as temperature, pressure, volume, number of mole, the system is undergoing to the change of state. So let us have a look, students. What is the then what kind of the change will be there, student? That is the change. These all the parameters, whatever the we mention, that is temperature, pressure, volume, they all are the state function. Okay, that is also known as thermodynamic function or state variable. Okay, now let us have a look over it, student. They are saying the fundamental properties which determine the state of system. The fundamental properties which determine the state of a system are referred to as state variable. Okay, let us have a look, student. Fundamental properties which determine the state of system are referred to as state variable. The change in state properties depends only upon the initial and final state of the system. Okay, what they are saying, student, the change in state properties depend only upon the initial and final state of the system, but in the independent of manner in which they change is known as what, student? State function. Okay, that is what is known as state function. Means that is, these are whatever they, student, that like pressure is there, so it is depending on P2 and P1. Okay, initial and final. If volume is there, student, change in volume, it is also depending into V2 minus V1. If temperature is there, student, temperature delta T, so it will be that T2 minus T1. If internal energy is there, student, it will be that is U2 minus E1. Or in enthalpy is there, student, delta H, this will be H2 minus what, student? H1. If that is entropy is there, delta S, student, the S2 minus S1, etc. So these are what, student? Their values, these are the parameter, thermodynamics parameter, which values are depending on initial and final. So this is what is known as, student, state function. That is what is known as state function. Now we are having that is properties of state function. Let us have a properties of state function. If state of a system is specified by the fixing the values sum of the state function, then the value of all other state function get fixed. In general, all state functions are not independent. Consider the gaseous system for which the algebraic relations known as the equation of state Pb equal to nRT exist between the state function. It is evident that only 3 of the 4 variable Np, Vt are independent and one is dependent for the gaseous system at constant mass. If we specify only 2 state function, the third automatically is fixed. So this is what the state function is all about, student, which value is depending on the initial and final. Now what we are going to have, student, path function. If change in fundamental properties depend upon initial and final state as well as the manner in which they change, means intermediate state has been brought about, that is what is known as work and heat. Example is work and heat. So if their values are depending on the intermediate steps, student, that is what is known as path function. Work and heat are the example of the path function. So this is all about our answer, student. Thank you so much for watching, dear students. So you might have to understand, student, state of the system. If the temperature, pressure, volume, number of moles of gas are constant, that is state of the system is fixed, definite state. But if you are changing the temperature, pressure, volume, so that is state of the system will be changed, students. Okay, so that is what is known as what change of state. Now that is two type are there are function are there, state function and path function. State function means that is the value depend on initial and final. Okay, and that is path function, it is depending on the initial, final, along with how they are proceed, that is the intermediate steps also. Thank you so much for watching, dear students.